Welcome to Chapter 5 in Video 5A. We're going to start the first of several sections where we're finding surface area and volume of different three-dimensional geometric shapes. This is kind of the section where when you think of taking geometry, this is what you think of doing. Finding areas, finding volumes, having shapes in two-dimensional, and in this particular chapter, three-dimensional. So this sheet right here with this table on it is going to be filled in bits and pieces as we go through the entire chapter, but this is what I'd have out when you're doing your worksheets and when you are doing the test because you're allowed to use it. So we are going to begin on the next page and we're going to fill that in as we go. So first of all, identifying solid figures. We have 5 kinds that we are going to have to identify. So let's split this up into different sections here. First is called the prism. And you call something a prism when it has 2 congruent, same size and shape, parallel bases that are polygons. Okay, so that's the first stuff. That's how you know you're looking at a prism. You name a prism by using the base name. And you might say, what? Here, I'll show you. Let's go over here and draw a prism. So I'm going to make a polygon. I'm going to make a pentagon. Okay? And now I'm going to make another one. I'm going to loft it up above. I'm going to make it as best I can the same size and the same shape. I'm going to connect these. Normally I try to do that dotted, but that's kind of hard to do on my smart board. So, and right here on the bottom, we call this the base. Notice I have 2 congruent parallel bases. When I name this, because this is a pentagon on the base, and I said you name it by the base name, I would call this a pentagonal prism, or a pentagonal, but I think it's more commonly called a pentagonal prism. My next shape is the cylinder. You should know what a cylinder looks like. A cylinder is just like a prism, except the bases are circular. So I'm just going to draw a picture of that. You should be able to recognize a cylinder. I'm not going to waste time giving the formal definition. There's a cylinder. Good to go, right? Next up, we have the pyramid. And the difference between a pyramid and a prism is the pyramid has only one base, has triangular faces, where you can see this has rectangular faces. Because there's only one base on a pyramid, I'm going to draw a square pyramid over here. It doesn't look like a square right now, but when I loft this dot up above like that, then I get kind of this square looking shape. And you'll notice that each face is a triangle because there's only the one base, and we have just one base. It meets up at a peak, but we still name it with its base. So we would call this a square, because it has a square base, pyramid. Next up, we've got our cone. And the cone is just like the pyramid, only the base is a circle, and you should know what a cone looks like, so good to go there. And lastly, the sphere, which looks like a basketball. So let's go practice naming a couple of these. What's this first one? This is going to be a pyramid because it meets up at that peak. It has the triangular faces. We name it with its base shape, which is a triangle. So we'd call this a triangular pyramid. Sphere, right? Cone. So let's go on to the next page here. We are going to be working with finding the volumes of prisms and cylinders. So let's go draw ourselves a prism, and we'll talk about how you get the volume of it. You know how to find the volume of one kind of a prism. I'm going to go off to the side here. You've been taught how to find the volume. I'm going to draw a nicer one here. of what we call a rectangular pyramid, also known as a box. And you were taught in elementary school that in order to get the area of this, you do length times width times height. But really what you're doing is the length times width gives you the area of the base, and then you're filling it up with the height. And that's basically the concept behind finding all volumes. So the volume of a prism, I'm going to write V sub prism, is equal to capital B. I want you to point what that means. That stands for area of the base. So you find your base, and then you find its area, just like here, like length times width, and then we pull it up with the height. So for any prism, we do area of the base. If it's a triangle, I have to do area of a triangle. Let's write that down. If it's a triangle, we have to do 1/2 base times height, do small b. If we have a rectangular base, we have to do length times width. If we have a pentagon or a hexagon, that's where we have to divide it up into those triangles and do 1/2 of it, the apothem times the perimeter and all that good stuff. So when we're doing the cylinder, V sub cylinder stands for volume of a cylinder. It's really got this same concept. The difference is for a cylinder, the base is a circle. The area of a circle is always pi r squared. And then we fill it up to the top with its height. So that's how we find the volume of prisms and cylinders. And I want you to go back to that chart 2 pages back, and we're going to add that to it. So for our prisms, remember we have 2 congruent parallel bases. In this case, I'm going to draw hexagons. Let's draw it a little nicer over here. 5, 6. Go up on top. 1, 2, 3, 4, 5, 6. Connect. Connect. Did I hit the right one there? Nope. Connect. Connect. This one will go to there, this one to here, this one to here, and here, go ahead and shade that in and point at it. That's what we call capital B in our formula. The distance between the bases is what we call H, and we just did the volume. We said the volume of a prism is capital B, H. And remember, these get labeled like in feet cubed or inches cubed or centimeters cubed. For the cylinder, we've got our circular bases, and we've got the height, we've got the radius, and our volume was basically the same as this. It's just that the area of the base is always pi r squared, and then we fill it up with the height. So, and again, because this is volume, all the volume ones will get labeled with the cubic units. So, moving back, we're going to be piecing that together as we go. This says find the volume. This is a prism. You might say it doesn't look like one. Well, it's just because it's not sitting on its base. It still has 2 congruent parallel bases. Go shade them in, please. Go point at that base. Call it capital B. Then you go find your formula, and you follow it like a map. The volume of a prism is the area of the base times the distance between the bases. And I think we'll add that up here so you understand. Sometimes we think height is always top to bottom. In geometry, it's the distance between the bases, which if it's sitting on its base is fine, but on this one, that's your height. So distance between bases. Same thing holds with the cylinder. I mean, if it's standing straight up like this, well, then that's the height. But if we're laying the soup can on its side, then that's the height. So it's the distance between the bases. So capital B stands for area of the base. That would be the area of this triangle. And how do I get the area of a right triangle? I do 1/2 of its base times the triangle's height. Then I need the height of the prism itself, which is the distance between the bases, which is 3. So when I do that, I get a half of 12, which is 6, times 3, which is 18. So that would be 18 cubic feet in volume. The next one, it's also a prism. We would call this a rectangular prism, not a square because this isn't quite the same. So we'd call this a rectangular prism. Go shade in the base. I think that's always helpful. Point at it, write B. The distance between the bases is the height, so point at it, write H. The volume is the area of the base pulled up or given its third dimension with the height. The area of this base is 5 times 6. It's just the area of the rectangle. This is just length times width times height. So 5 times 6 times 7, which is 30 times 7, which is 210 cubic centimeters. Next, I've got a cylinder. My volume for a cylinder is pi r squared h, and I plug these in. So I do pi times 8 squared times h, which is 7. So this is h, this is r. And then you'd go to a calculator and you would enter that. And that's one of the things I'm going to check when you come up and see me, is that you finished these problems off. Because if I use my calculator, then I'm not confident that you're just writing them down. So you need to go and enter that on your calculator. Your calculator has a pi button. If not, go ahead and use 3.14, but the more we round, the farther off we get from the exact answer. So next up, how about the surface area of those things? So we're not going to fill them up. We're going to cover them in paint or wrapping paper, or whatever you want to think of. But we are going to do the surface area, but of those same two shapes. So with our prism, again, I'm going to draw one. I'm going to draw, I think, let's do a pentagonal one. Okay, so let's try to make these look like they're the same. Not so good. I'm going to reboot that. Try to draw that a little better. Come on. It's being finicky. All right, so let me try to draw that a little bit nicer. So a pentagon on the top, a nearly identical pentagon on the bottom, as best I can. I'm going to connect these parts. Here's my base down here. But I'm going to be doing the surface area of this. So it's like I'm wrapping all of the edges. And I want you to lay it out. Pretend I cut this open, and I cut it open here, and I laid it flat. What would I be seeing? I would have, if I laid this flat, I would have 5 rectangles, because I've got one here, one here, one here, one here. So I'm going to draw 5 rectangles so you can see it. 1, 2, 3, 4. Let's go about to there. So I'd have the 5 rectangles laid flat, and then off of any of those rectangles, let's say I cut it here, I would have these 2 pentagons shooting off. So it's kind of like if I wrapped it, again, I took this 3-dimensional figure, I took the wrapper off, and I laid it flat. That's actually called a net. But you'll notice what I'm looking at for the surface of this. I'm not inside it, I'm using the surface. I have 2 of these bases. So in my formula for surface area of a prism, I for sure have to cover, again, if I'm painting this, I'm going to paint the bottom here, I'm going to paint the top here, and then I'm going to paint all the sides. And the sides are all these rectangles. So I have 2 of the bases plus all of those rectangles. Is there an easier way to do it than adding up 5 rectangles? And the answer is yes, because each of these rectangles, its area would be base times height, base times height, base times height, but for each of these, the height is the same. And when I do the base 1, base 2, base 3, base 4, base 5, really what I've got is the perimeter of this pentagon right here. That's going to create all those side lengths. So we do 2 of the area of the base. Again, write that down. Capital B in this whole chapter is area of the base. Capital P is perimeter of the base, or distance around. And h is the distance between the bases. For the cylinder, now we have circular bases. So again, picture me laying this flat. It's kind of like picture a Campbell's soup can. I'm going to strip off the label on my soup can, and it's going to be a rectangle. But I also have the top of the can and the bottom of the can. So I'm going to get the surface area of my cylinder is going to equal 2 of these circles. It's really the same thing as over here, 2b, but my bases are circles, so there's a 2 pi r squared plus, and I still do the perimeter of the base, this, times the height. But this length right here is the circumference of the circle. Again, picture taking off that Campbell's soup label. The length of the label is the distance around a circle. That's how it wraps around it. And the distance around a circle is its circumference, or 2 pi r. So we need the radius and the height for the cylinders. So let's go find the surface area right here. The surface area of my cylinder is going to be 2 pi r squared plus 2 pi r h. Again, you just grab the formula and then you follow it like a map. Pi is a number, it stays in here. The radius is given to me, I replace it with a 4. 2 is a number, pi is a number, radius is a 4, height is a 7. I'm going to write this answer in terms of pi. Pi is a number that goes on forever, never repeats, so I'm not going to round it. I'm going to do 2 times 4 squared, which is 2 times 16, or 32 pi. Again, I'm going to do everything but the pi. I'm going to do 2 times 4, which is 8, times 7, which is 56. If I were to say, what is this answer in terms of pi, sometimes they have that on like the ACT or MCA or something, I would say 88 pi. And again, if these were labeled, this would be in feet squared because this is two-dimensional. This is the wrapper, all right? Or if I were to paint the can. The volume is if I'm filling the pool up with water. The surface area is if I'm covering the bottom and all the sides and putting a cover on my pool. All right, and here's the net for it right here as well. So that one's done. We have another one on here, or is this the end of this video? Almost to the stop sign. Again, here's what we would call the net for it, but we're just going to use the formula for this. This is a prism. Here's the base right down here. So the volume of my prism is going to equal, and you can go snag that formula, I do 2 times the area of the base plus the perimeter of the base times the height between the bases. Well, I need to figure out what capital B is, and I'm going to do that off to the side, and we did that in another section. Remember, it's all about chopping these into triangles. There's 5 of them. So the area of that base is going to be 5 triangles. Each triangle is 1/2 of its base, so 1/2 of 13 times its height, which is, this is pointing in there at the height, which is 8.9. That is the area of my base, all right? 5 triangles. Every triangle is 1/2 base times height. And I'm just going to go plug that in. Now that's just this, and I have 2 of those. So I have 2 times capital B, which is 5 times 1/2 times 13 times 8.9. You can just do that all in one big swoop on the calculator, which I'm not going to do. I'm going to make you do that. The perimeter of the base, let's go erase this for a second, will be this plus this plus this plus this plus this. They're all 13, and I have 5 of them. I could do 13 plus 13 plus 13 plus 13 plus 13, but why not just do 13 times 5? Times the height of the prism, which is the distance between the bases, which is 8. Then you run that whole thing through your calculator, and out pops the surface area. So it's a little trickier section. It's going to take you a little bit more time. Showing your work is crucial in this section, so make sure I don't see just answers sitting on your worksheet, and make sure you have a calculator, and make sure you use the chart